Geometry 8-6, the law of sines and the law of cosines. So here's the law of sines. And we use this when we have angle, angle, side, and angle, side, angle. So you'll see what I'm talking about in just a second with this. So we can use law of sines and law of cosines to solve triangles that are not right triangles. So if this is triangle A, B, C, and this is not a 90-degree angle here, so this side is C, this side is A, this side is B, we can use a proportion to solve this triangle. So we can find all of the angles, we can find all of the sides that we're missing, as long as we have certain specific information. So the law of sines is this: sine of angle A over A equals, so that's the side down here, sine of angle B over side B equals sine of C over side C. So let's do an example here and see if we can figure out what's happening. Here is a triangle. A, B, C. And I want to find this value here. Here's the information I have. BC is 16. Angle C is 21 degrees. And angle A is 97 degrees. Okay, so now what do? I'm going to use this here to find this. Now, I can use law of sines when I have an angle and an opposite side that's the same, that is the opposite side from that angle. That's generally if I have that information, I can use law of sines. So I'm going to say sine of 97 degrees, which is sine of A, 97 degrees, over 16 equals sine of 21 over x. So I take the angle and I put it over the opposite side. I take the angle, put it over the opposite side. And now, this is a 21 here, now I can just solve for x. So I do cross products here. X times sine of 97 equals 16 times the sine of 21. Divide both sides by the sine of 97. Sine 97, and those go away. So now x equals 16 times the sine of 21 divided by the sine of 97. So I just plug all that into my calculator. So I say, I just start with parentheses, 16 times sine of 21, and parentheses for the sine, and parentheses for the numerator. Then I divide it by the sine of 97, and parentheses, and then I get 5.78. X is approximately 5.78. Now, you might do the sine of 97 first, and you get 0.993, blah, blah, blah. You might do sine of 21 first, you get 0.358, blah, blah, blah. And so when you do that and you get down to the bottom, you might end up with 5.77 instead of 5.78. So there's some rounding issues that might occur if you do that. But we're pretty close. Okay. Let's do another example. A, B, C. BC is 8. Angle B is 60 degrees, and angle A is 78 degrees. I want to know what AC is here, this value. So I'm going to set this up. I've got A and 8. I've got 60 and X. So just like up here, the angle and the side across from it, the angle and the side across from it. Same idea. So let's go sine of 78 over 8 equals the sine of 60 over x. Now this time I'm going to find these values before I start doing all of this mess, just to do it a little bit differently so you can see it. So I'm going to go sine of 78 is 0.9781, and sine of 60 is 0.8660. Okay, now I'm going to multiply, I'm going to cross multiply here. So 8.660 times 8 is 6.928 equals 0.9781 times x. So now I just have to divide both sides by 0.9781. And so 6.928 divided by 6.928 divided by 0.9781. I get approximately 7.083, which is about 7.1, depending on what they tell you to, where they tell you to round. So there you go. And let's do law of cosines now. So that's how law of sines works. Here's law of cosines. And this is when I have side angle and a side, or side, side, side. So law of cosines, let's draw a triangle that's not a 90-degree triangle. And this is A, B, C this way. So this side is C, this side is A, and the side across from angle B is side B. All right, so law of cosines has three different formulas here, and they're all kind of, they follow the same pattern. If so I'm going to start with side A squared equals B squared plus C squared minus 2BC times cosine of A. All right, so here's the pattern. B squared equals the two that are left, A squared plus C squared minus 2 times the two that are left, A times C, times the cosine of the angle that is across from that side, cosine B. So you should be able to tell me what the third formula is here. It should be C squared equals A squared plus B squared minus 2AB times the cosine of C. So those are, that is the law of cosines. And let's use it. So you see this is way messier than the law of sines. So if you can figure out a way to use law of sines instead of law of cosines, use law of sines. It's way easier, but you know, if there are times when you need to use law of cosines. So here's an example. A triangle, ABC, and I want you to find AB. AC is 11, BC is 9, and angle C is 28 degrees. All right, so the only angle measure I have here is C, so I'm not going to be able to use the law of sines. It's not going to work. So I have to use the law of cosines, and I have 28 degrees here, and I have this x here that's across from it. And so this is the information I'm going to use to solve for x. So I'm going to start with the side. x squared equals my other two sides, 9 squared plus 11 squared, minus 2 times my two remaining sides there, 9 times 11, times the cosine of the corresponding or the opposite angle there, so cosine of 28 degrees. All right, so now we just need to simplify. X squared equals 81 plus 121 minus 2 times 9. Which one? What am I going to multiply? I'm just going to put it in the computer, in the calculator. How about that? 2 times 9 times 11. 2 times 9 times 11. That'll get me 198 times cosine of 28. I'm just going to leave cosine of 28 alone for a minute. I'm going to add these two together. This is going to get me 202, right? Now I'm going to finish this. Yeah, I guess I'm going to do all this mess now. Cosine of 28. Let's find the cosine of 28. That's 0.8829. So I'm going to say 0.8829. Now I can say 202 minus these guys. Let's multiply 0.8829 times 198 and then subtract that from, so that's 15.8922. Let's subtract that from 202 and I get x squared equals, oh, did I do something wrong? Let's try this again. Cosine of 28, yep, okay, so I'm going to say 198 times 0.8829, oh, there we go. When I multiply this stuff together, I get 174.8142. Then I subtract that from 202, and I get 27.1858. I take the square root of both of those. So I find the square root, and I say 27.1858, and I get x is approximately 5.214. It's as easy as that. Now we've got another couple to do here. Here's another example. This is DFG. DF is x, DG is 15, angle G is 125 degrees, and GF is 19. So again, we've got a law of cosines issue here because I don't know these two, this side or this and this angle. I have to find out what this side is. So I'm going to take that side that I'm looking for, x squared, set it equal to the two sides that I know, 15 squared plus 19 squared, minus 2 times 15 times 19 times cosine of 125. That's all there is to it. All right, x squared equals 15 times 15 is 225, 19 times 19 is 361, minus 570, which is 2 times 15 times 19, cosine of 125. 225 and 361 is 586 minus 570 cosine of 125. All of that is equal to x squared. Now when I plug all of this stuff in my calculator here, I get x squared equals 912.92. I rounded that a little smaller than usual last time. Take the square root of both sides, and x is approximately 30.2. And sometimes you got to take a look. Does that make sense? 125, right? That's a pretty wide angle. And if this is 15 and this is 19, this should be a bit bigger, a bit longer than these other two sides. So 30.2, that sounds right. Okay. We've got two more examples to do. Here is another example. And this one we're going to need to use law of cosines again. This time I have x degrees, and this is 8. This is triangle MPQ, by the way. And then I've got MP is 3 and MQ is 6. So now I have a very similar situation to the last two that we've done, but this time I'm looking for this angle. So now I've got all three sides, but not this angle. So I need to look at these two here. This is where I'm focusing my, my law of cosines. So I'm going to say 8 squared equals 3 and 6, 3 squared plus 6 squared, minus 2 times 3 times 6 equals, oops, not equals, sorry, times cosine of x degrees. 8 squared is 64 equals 9 plus 36 minus 2 times 3 is 6 times 6 is 36 cosine x. Okay, so these two together make 45. So I'm going to subtract 45 from both sides. 64 minus 45 is 19. 19 equals, what's left over here? Negative 36 times cosine of x. Divide by negative 36. And so now I have this mess. Negative 19 over 36 equals cosine of x. Now this is what I do. I want to find the angle, so I take the inverse cosine of negative 19 over 36, and that's going to get me my angle measure. That's going to get me x. So I just plug that into my calculator. Inverse cosine of negative, oh no, where's the negative sign? There it is. Negative 19 divided by 36 in parentheses equals 121.8. So we round that to approximately, since it's an angle measure, we're just going to round that to the nearest degree. So x is approximately 122 degrees. And last example, here we're going to go. I've got JKM. Angle J, I don't know. Across from J, I got 1.9. JK is 2.1, and JM is 1.3. I want to know what X is. Okay, so what I'd like you to do is try this out on your own, and then we're going to look at it together. So this would be a you try. Okay, go. All right, let's see how you did. We've got X and 1.9. These are the focus for my cosine, law of cosines. So I'm going to say 1.9 squared equals 1.3 squared plus 2.1 squared minus 2 times 1.3 times 2.1 times the cosine of x. All right, pretty gross. Okay, 3.61 equals 1.69 plus 4.41 minus 5.46 cosine x. So that's what all of that mess looks like. These two together here become 6.1. So I'm going to subtract 6.1 from both sides. So I end up with negative 2.49 equals negative 5.46 times the cosine of x. Divide both sides by negative 5.46. So those go away. And now I need to do the cosine, inverse cosine of negative 2.49 over negative 5.46. But do I need to put those negatives in? No way. Negative over negative is a positive. Equals x. And so x, if I plug all that into my calculator, I get x is approximately 63 degrees. And that is law of sines and law of cosines, and that is the end of chapter 8. Good luck on the homework. Get ready for an awesome test.